Alright, so in this video we're going to be going over synthetic division. Synthetic division is a shortcut way to divide a polynomial by a linear factor in the form x minus a. If long division with polynomials feels really slow or messy, this trick is going to save you a lot of time and energy in exams. But that's only if you use it correctly. So today I'm going to be showing you guys how to use it, how it works, and a few different cases. An important thing to remember is that synthetic division only works when the coefficient of x is 1. If the coefficient of x is not 1, you're going to have to adjust. And I'm going to be going over this later. So let's do an example. Every synthetic division basically follows the same pattern. First thing we do is equate the divisor to 0. So x plus 1 equals 0, x equals minus 1. So write minus 1 here. And then we write out our coefficients in decreasing powers of x. So 1, 3, and there's no term independent of x, so 0. Okay. The first thing we do is bring down our first coefficient as it is. So 1. Now you multiply and you put the product here, minus 1. And then you add minus 1 and 3, which gives you 2. You basically just like multiply, add, repeat. So now you do minus 1 times 2, and you put the product here, minus 2, and you add. Your last number is always your remainder. And these two are the coefficients of the quotient. So the answer for this is x plus 2 minus 2 upon x plus 1. Okay, let's do another one. So we'll do the same thing as before. We find the 0 of the divisor. X equals 2. 2. We write out the coefficients. Now, same thing, we bring down the first term. 3, multiply, add, and repeat. And your last term is your remainder. So here we get 3x plus 4 plus 3 upon x minus 2. Okay. So here, the coefficient of x in the divisor is 2. So first let's solve this as we normally would. So 2x plus 1 equals 0, x equals minus half. This is the same 0 of x plus half equals 0. And I'm going to be showing you the difference between dividing it like that and dividing it like this. So first let's divide this. We take minus half out. 4, minus 8, minus 1, 5. This time we have 4 terms. You can use synthetic division for any amount of terms in the numerator. Right now it's a cubic. You could do this for a quartic. You could do this for if x was to the order 5. It's exactly the same thing. You bring down the first term. You multiply. And add. You multiply. And you add. It's just multiply, add, repeat over and over again. And your last term is still your remainder. So we get 4x squared minus 10x plus 4 plus 3 upon 2x plus 1. Okay, this would be your answer if you were dividing by x plus half. But here, the coefficient of x is 2. Now, what does that actually do? So, like I said before, synthetic division is only really built for x minus a, right? So here, what we'll imagine is, okay, this is your factor theorem, where the dividend is equal to the divisor multiplied by the quotient plus the remainder. The dividend is ultimately the same, right? because x plus half and 2x plus 1 are almost the same. But what 2x plus 1 but for 2x plus 1, the synthetic division does not account for the extra 2 that you're adding, that you're multiplying. These are basically the same, except you've put a 2 here. You've multiplied this by 2. So what you do is you divide these by the leading coefficient of x. So we divide by 2, so the answer for this would be 2x squared minus 5x plus 2 plus 3 upon 2x plus 1. As you can see, the remainder is not changing, so that stays the same. So yeah, synthetic division is a really useful, faster way to divide polynomials as long as your divisor is linear. And you have to adjust and be careful in case your divisor has a coefficient other than 1. Okay, thank you. If you guys have any questions, you can ask in the comments or on the WhatsApp channel linked in my description. See you.